Sneha Sarkar. Sarkar. I couldn't read your writing, Sneha. Honey Shah. Dushyant Shannon. Vivesh Shah. Looks like we're Shawless. Shruti Sharma. Oh, she is here. Yeah, thank you. Wang Cheng. Wen Bo. Wu Kun. Xing Yuxian. Best I can do, Xing. Zhu Datan. D-A-T-A-N. Yao Zexen. Zhang Jiecheng. Zhang Qinshi. Zhang Jiaohan. Zhang Zhu. Zhou Weizhu. I'm going to go over these one more time quickly. Gauri Ambekar, let us know if you're here. Vishnupriya Bathisaran. Ashwani Bhatt. Swapnil Borsh. Ankita Gadji. Ankita. He Yang. Saloni Jain. Ki Lingyun. Lin Yuan. Swapnil Mundra. Sayali Naval. Honey Shah. Vivesh Shah. Dushyant Shioran. Is there anybody here who thinks they should have gotten one and didn't? Good. Thank you. Okay, let's talk about solutions. So, whoops, this is wrong. You'll see here I've indicated, good answer to a question about ideas and principles, discusses the ideas and principles, how they will be used, and gives brief examples. It's an ideal answer for a principle question. Good answer to a code question is brief, clear code that does what is asked and very little more. And again, I note with irony that I sometimes do a little more than that myself. Okay, but mostly to instruct, I think. Grades are based on contents of the answer and clarity of the presentation. So, every time I hand back midterms, I'll get 2 or 3 people who come to me and say, my friend, I did exactly the same thing as my friend, and we got different scores. He got a higher score than me. And my answer will be, tell your friend to come in so I can deduct points from his score. That's what I do. Okay. So what's going on here is if your friend and you stated the same things, but he did it very clearly, and you did it in a way that's hard to understand whether that's really correct or not because it's too vague, then he's got to get a better grade. That's the way it is. I Don't pay any attention to the quality of the English grammar. Okay, so it has nothing to do with your grade. When I grade these exams, aside from the very first question on the first exam, I don't know who I'm grading. Because I have a stack, and I grade all the ones, and then I sweep back and I grade all the twos, sweep back, grade all the threes. So I don't know who I'm grading. You know, they're all folded, and I just pick up the next one. So I do that intentionally so that I don't, you know, I try to be unbiased. So whether I know you well or don't know you well. Also, that helps me be consistent about the way I grade, you know, because I'm grading all the project ones, and then all the question ones, and then all the question twos. So I try really hard to be fair. Okay, so write all code for a class that wraps any C++ primitive to enable instances of the class to behave like a primitive, but may add additional functionality. Hint, you will need constructors and assignment operator to accept a primitive value. You'll need a cast operator. So this is one of those, what on earth is he talking about? What's this crazy guy doing? Well, let's take a look at this code first before we look at the answer. This was midterm 3Q1. And I put that in here. Where that is in the code, code utilities. So here's this. I called this class box because it's very much like what I'm trying to do is wrap a primitive, short, long, int, double, float, in a class. It's exactly what C# and Java boxing do. Okay? Why? So that I can add some additional functionality. So could be a toString function. I was doing this to do a toXML. So you know, here's all the constructors and assignment operator, and you know, and they're a little weird. Okay, they don't use exactly the same terms that you're used to because we're wrapping a primitive. All we're trying to do is pull the primitive in and push it back out again, you know, with the cast operation. So, and I defined a toXML interface, so I'm going to add toXML. So here I have a persist factory, public T. So you can't inherit from a primitive, but you can inherit from a box primitive because it's a class. Okay, so this T is going to be box of double or something. And then XML. So I can have my XML say, I can have my boxed double say, here's my XML. So if you look at the implementation, you know, here's box double, blah, 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 boxed int, blah, blah, blah. It works. Now here's the persist factory. So name to XML, value to XML, value to XML, I value to XML. Let's see how it works. So let's set this as startup. And run it. And sure enough, if it's a string, all I'm doing is wrapping it with tags. You know, if it's a string, if it's a double, if it's an integer, piece of cake. That's what that strange question was all about. Okay. I know from some of your answers that it was really, you know, what is this guy talking about? This crazy guy. But that was the model. So, you know, so that's that. State the interface segregation principle. Have you applied ISP in your implementation of Project 1? So clients should not be forced to depend on interfaces they don't use. And we used it extensively in Project 1. Because in Project 1 we have a DB core, and a persist, and a query, and an edit, and if you don't want to persist, you don't have to use that interface. It's not forced on you. You just don't use that class. So it absolutely is interface segregation. You know, it's not using mix-in inheritance, which is the one way I described in implementing the interface segregation principle, but it's absolutely interface segregation. The query guy has an interface just for querying. The persist guy has an interface just for the persist. The DB core has the basic DB operations. The editing has editing of DB elements. Okay. So absolutely interface segregation at work there. Now, some of you cited iPayload, and that's the one place in Project One where we're not using interface segregation, because iPayload is that all the payloads have that same interface. So because we're reusing that interface with different types that implement the methods in a different way, that isn't interface segregation. That's a polymorphic list-graph substitution, but it's not interface segregation. Following the single responsibility principle, like we did in project, like I did in project, like we all did, I hope, in Project One, is likely to segregate interfaces. It is. But following interface segregation principle does not imply that single responsibility principle is used. I can segregate interfaces, but have doing all kinds of different things. Okay, so they're not equivalent. This is just saying, you know, segregation. So single responsibility principle is very likely to imply interface segregation, but interface segregation does not necessarily imply. It's not an equivalence relationship. They are different principles. Write all the code for a function that accepts a callable object and executes it. If execution throws an exception, the thread running your method should sleep for a specified amount of time and then retry. It should do this for a specified number of times before returning a failure. Now, I have a bunch of stuff here. Let me go. I have two solutions for this. This is midterm question 3. So, midterm 3, Q3. So let's look at midterm 3, Q3B. So this is a minimal implementation of that, you know, the code for that question. So it accepts a callable object, accepts a time duration, accepts a max count, you know, and so what it does is it sits there in a while loop, tries to execute. Boy, that isn't clear. That isn't much better, but it tries to execute it, and if it succeeds, it just returns. But if it throws an exception, we start counting, sleeping, trying again, you know, just keep going around. And if it succeeds before it gets to max count, it just returns. So you'll see fail, 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 and then succeed. If it goes through all the max count, then it just returns false. I couldn't do this operation at this time. Now, why this in this form isn't all that useful? It's okay. Answers the question. But my answer made it useful. So what I did was I added a couple of things. So what I want to do is I want to be able to open a file. And if it fails, so here's a repository, somebody else has that file open, I want to be able to open that file, you know, try to open that file, and if somebody else has got it open, I'll wait a little while for it to finish. You know, I probably have a higher count than I think my default count was 10, and you know, I'd have a longer sleep time and a higher count, yeah, for the repository, but you know, it's just a really nice way of making it likely that that repository operation will succeed. So let's see what you have to do to make it work for a file thread. So let's go to, let's set MT3Q3 as startup. And so here I've added to it, I added a return type because I'm trying to open a file and I've got to return the stream. Not much point in opening the file if I can't give the client access to the file. So I need a return value, and I need an error policy because what do I return if it fails? So I made sure with this error policy, so here, same thing, except now I'm accepting this return, and if it succeeds, it just returns with a, in this case, a file stream. We'll see when we, in the CPP part. But if it's error, I'm going to use I have an error policy. This is a nice, classic application of template policies. This lets me tailor what happens to that return type if I don't succeed. And what I do is I'm going to set, this is what, in my specialization you'll see in the CPP file, this is what set error state does for streams. I do a dynamic cast to make sure that this is a stream, and then if it's not a null pointer, if it's a null pointer, I know that it didn't open. But if I can get back a non-null pointer, but I make sure that that stream state is set in the failed position, okay, to indicate that it failed. So let's look at the CPP part. C3Q3. Let's go to the CPP part. So here's the CPP part. So here. This is just a little printout for the demo. Here's my specialization of the error policy, just what I said I was going to do. And now, so what I'm doing is I have a function open file for reading. And by the way, you can open this in shared reading. The standard, this is not standard C++, but this is platform specific, but it can take an argument for shared reading. Okay. So, and this is shared deny write access, so that means that if I'm open for reading and another attempt to open for reading, it just opens. But if I've opened for reading, if I get a request to open for writing, that will fail. Because I'm reading, so a writer shouldn't be allowed in. If I'm opening it for writing, then I deny read write. I don't want another writer. I don't want a reader. That writer needs exclusive access to it. So, so I have those two functions, and now I'm going to use them. So here, OFStream out equal open file for writing. Okay, and so. Okay, so now I just open the file for writing. I know this is going to succeed because this is a demo and it's the first one I'm doing. Now I am going to open another file for writing. I'm sorry, I opened this for writing. I'm going to open another file for writing, and that should fail. So now I'm trying it. I'm using my retry function on the. I didn't use the retry function on the first one because I know it's going to succeed, but I used it on the second one. And, I use these aliases to make it a little shorter to write. So it's just, my return value, my callable object, my argument, and the stream policy. And what I'm doing is I'm passing it open file for writing, that function. I'm passing it the file spec, the file I want it to open. And I'm passing this SEP, my specialization of the error policy, stream error policy. And that will fail. And now I close out 2, okay? And now I attempt to open it for reading. This should still fail because I got it open for writing. That still fails. Now I'm going to close that first one that was holding everybody. So now everything is closed, and now this should succeed. Now I'm opening it for reading. It should succeed, blah, 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 blah. So if we run it, so my first one opened. Now I'm retrying. He's got it open. He's going to hold it open, you know. And so the operation failed. And now I'm going to open it, trying to read it, and that's going to fail. Now I'm closing out, attempting to open. Sure enough, it succeeds. Attempting to open. Sure enough, that succeeds. So I'm just opening 2 for reading just to show that that shared reading works. Okay. And for no good reason, I displayed the bytes that I'm reading out of that file. And if you compare it, the file just has first line and second line in it. And if you look at the bytes, you'll see, yeah, it's. So that's that. Again, no requirement to use RET, ARG, or error policy. And see the MT3B code. So that's the simple answer, but it takes this to make it really useful. This I can use for almost anything. But the main place you want to use it, of course, is for file streams. And that'll be useful for Project 4, where you'll have multiple concurrent clients. I like to put stuff in my midterms that may be useful for projects, for the succeeding projects. So I won't promise you that every question, it's certainly not true that every question is that way, but a few of them are. And so before you go heavy duty into implementing Project 4, you probably want to look at all 4 exams to see if there's some useful goodies there to give you a hand. You're preparing to design a class that may need to be extended in the future in ways you can't anticipate. How might you do that? Templates, inheritance. Bang! Yes, of course. So I can use templates with template policies. Okay, modify the way a template class behaves, substituting appropriate, provide template methods that accept callable objects. So this is different. This is what I did in the query. I have a select as a template member, and that absolutely allows me to extend. I didn't, you know, I can make any kind of query for any kind of application that needs it. The repository may need one class of queries, but some other application might need a totally different class of queries, and it'll work just fine. Use inheritance and polymorphic classes. We can extend an inheritance hierarchy simply by adding new derived classes. Use interfaces and object factories. This is a elaboration on C. D really is elaboration on C. And then E, I can add additional interfaces and support querying from one interface for another, just like we did in the object factory demo in lecture 12. That was a complete answer. What methods are not inherited by a class derived from its base class? How does that C++ language ensure that Liskov substitution works for derived class pointers? So the class, the constructors, the assignment operator, and the destructor the class uses are not inherited. All those methods are inherited from the base, but they're not the ones used by the class. If you go and look at the compound objects, you'll see me use the inherited base operations to implement the derived operations. So C++ guarantees that every single method, whether it's virtual, non-virtual, public, protected, or private, they're all inherited. But the ones used by the class, the constructors, the assignment operator, and destructors used by the class are not the inherited methods. Obviously, the inherited is B, the derived is D, the different, they're not. And the assignment operator is kind of a special case because what happens is if you've explicitly defined an assignment operator, you probably use the base inherited to assign the base part, but that isn't the one that your class is using, the one you implemented. And if you let the compiler generate it, it does the same thing. The compiler just calls assignment on each of the bases and assignment on all the members. It delegates its assignment operation to each of those bases and each of those members. And if they have correct semantics, it works correctly. So default constructor will be generated only if no constructors are declared. Copy constructors will always be generated if needed and not declared. Move constructors will only be generated if no copy operations, assignment operations, nor destructor are defined. Copy assignment will always be generated. Move assignment, again, just like move constructor, will only be generated if no copy assignment or destructor are defined. Destructor is always generated if not declared. Voila. The compiler-generated operations simply apply the operation to each of their bases and data members. These will be correct if each of the bases and members have correct assignment, construction, assignment, destruction semantics. And there's a footnote coming we'll look at in a second. Since all other methods used by the derived class are inherited, here comes the Liskov substitution. Since all the other methods used by the derived class are inherited, that means all of the methods of the base are available in the derived. So Liskov, a pointer to a base class operation, is guaranteed, if I make that call, there's going to be a receiver to get it. Whether it's base or derived, doesn't matter. It's the fact that all the methods that are not used by the class, that are not inherited, are generated if they need to be. Either you generate them or the compiler will. Guaranteed they are there. That was what this question, that was what this part of the question was all about. Whoops, that was what? How does the C++ language ensure that Liskov substitution works to the derived class pointers and references in code that they may use? Because every single method is there. Either inherited or constructed or generated. The footnotes say, technically, all the methods are, just what I said before, all the methods are inherited, but construction, assignment, and destruction used by the derived class are not inherited. The base ones are there, but the base ones aren't the ones that your class uses. You know, it does indirectly, but it's using, the constructor that's called is not the inherited constructor. It uses the base in executing its job. Part of its job is to initialize the base. It is incorrect to say that the compiler-generated functions are shallow. I hear this all the time. That's absolutely false. False, false, false. They simply delegate to the base and member operations, which, if needed and correct, are deep. If you have an owning pointer, then the operation is incorrect because that member doesn't have correct semantics. If it's a pointer, it will be a shallow copy. But because it's compiler generated, doesn't mean it's shallow. If the semantics are correct, it'll be deep if it needs to be deep. C++ is a really elegant language. It does things the right way. It really does. Super. So every method of the base class is present in the derived class, either by inheritance or by compiler generation. And you can break that by using equal delete in one class and not using it in the other class. I hope that would fail to compile, but I haven't tested it. I think it probably won't fail to compile. I think it would just break. So I don't know. I hope it would fail to compile, but I've never read anybody talking about it, and I've never gotten around to checking it. What are template policies and template traits? Have you used them in your implementation of Project 1? The answer is sure. Maybe. A template policy is a template parameter used to modify the operation of template class, does not replace the primary functioning of instances of the class, but only modifies how they carry out their operations. See the answer to question 3 for an example. Okay, so that was the error policy. Okay, template policy for the streams. You can also argue that the parameter of a template method in a query class used to accept callable objects is a policy. Policy that modifies query instances to support user-defined query operations. That's a gray area. You know, do I call that a policy or not? But you know, I'm happy if you did. A trait is an alias for a template parameter type that provides an immutable name, a fixed constant name that you know that isn't going to change, irrespective of how that class is instantiated. So value type is always VALUE underscore TYPE, even if the type is string or int or double, it doesn't matter. It's always value type because that type def, that alias sets it to be that. Traits allow us to write code in a template function or class that depends on specific type of the template parameter without knowing how the application will instantiate. The DB core iterator from Project 1 is an example. How can you safely retrieve a value computed by a C++11 thread? And I have some example, but my answer is two common ways to do that. First and preferred is to use standard async, which returns a standard future, or you can write the equivalent of it. I've shown you how to write it. Second, you can pass a C++ standard thread an argument by reference. Then after joining, access the value of the argument. That's, you know, essentially unsafe because, you know, while in this demo it's safe, the problem is that because you've declared it here, you know, not inside the scope of some function, now some code later on in main could use it, and it's not going to be locked. It's accessible and available. So the point is that you never try to use it until you've joined. That's the only thing that's to say. Ensure that you don't use it. And the only way to ensure it is really to wrap it. And in my code, I did this this way, but I also did it, I wrapped it in a function. So let's go take a look at the code. So we looked at midterm 3Q3 and 3B. Here's midterm 3.7. So, you know, here's first meaning of life, second meaning of life. And so here, I can use standard async, you know, perfectly safely. Here I'm using, you know, I'm declaring this meaning of life, and so it's unsafe for me to use it until I've joined it. But if I look at, I thought I did a B version of this. I guess I didn't. Somewhere, it must be in the next exam, I did a version of a question very similar to this, and I wrapped it in a function. So we'll see that when we come to exam 4. Okay, so let's look at exam 4. Write all the code necessary to find all the parents of a DB element stored in a record of the NoSQL DB you implemented in Project 1. You may add code to the DB core P if you wish. Remember that each database record's metadata contains a collection of children, not parents. Now, I want you to observe something here. So there's two really simple functions. Please, no conversation. Two really simple functions. Contains child key. You probably already implemented this. Contains child key. You know, just use find, step over all the elements, use find. And now here's the parents. So parents is an alias for a vector of key. So here's my parents. If auto item in DB store, if item.second contains child key, it's got to be a parent of key. So parents push back, return parents. That's it. That's the whole thing. And it's very obvious. Some of you wrote a whole page and a half of code for this. Okay. You really, you know, what you want to do is do your very best when you are deciding how to implement something, to chisel away all the complexity until you're left with something really simple. I think it was Tony Hoare that said there's two ways to design software. One is to make it so simple that there are obviously no deficiencies. The other way is to make it so complicated that there are no obvious deficiencies. And he says the first is harder. He's right. But that's the goal, always to chisel away all that complexity and come up with something really simple. And you can look at it, no way you can misunderstand what's going on here. Cut to the bone, just doing exactly what it has to be doing. So, okay, so see how easy it is to understand what these functions are doing? That's craft. That's our craft to do that. Oh, that's trivial. That's good. That's good. Might be useful to find a query like this, so you don't have to look at all the keys in the DB. So, and you can see almost immediately how to do that. So, piece of cake. 2, name all the design principles discussed in class. Which of these does the XML document facility you've used in Project 2 satisfy, and which does it not satisfy? And I got a lot of answers I wasn't too happy with on this question. Remember, this is the XML element. So list call substitution is used because I have an abstract XML element interface. All the concrete elements derived from that, I'm accessing it through shared pointers to that base abstract class. So absolute list call substitution principle is used because each of the types has a factory function, make tagged element, make text element, and so on. This is also dip. Because dip is essentially interface and object factory. If you have an inheritance hierarchy that based on an interface and you provide an object factory, you're using dip, dependency inversion principle. Interface segregation principle is not used for the XML element classes. However, it is used because the XML document class focuses on its interfaces specific for handling document activities, while the XML element class focuses on configuring the XML elements. So the document and element stuff was segregated. So it is using interface segregation. Open-close principle could be used to add new XML elements, but that isn't likely. That XML has been standard and unchanging for the last 10 years. So it's not likely that you'll use open and closed here, but the opportunity is here. Should someone invent a new XML element, then you'll definitely be using OCP. Single responsibility principle is used effectively in the XML element hierarchy. Each derived class focuses on configuring a specific XML element type. The XML document class focuses on managing the XML document. I named some more. Least knowledge principle, single responsibility principle is used effectively. Least knowledge principle, value semantics principle is not used as the XML element classes and document class remove copy operations with the equal delete syntax. So it's absolutely not a value type. Scope-based resource management is used because all the XML element instances are accessed through standard shared pointers. Encapsulation principle is used. So, and I made the comment down here that all of these principles are described in CSE 687 Notes and Design Principles. The first 4 items are a complete answer to this question for grading because those are the ones I stressed in class. If those are the only ones you mentioned, fine, you could get a 1.0 answer just talking about those 4 because those are the ones I stressed in class. I am occasionally mean, but I'm not that mean to take off points for things that I didn't talk much about. They're important, but. Okay. So let's go back and look, see if we looked at all the code that we need to look at. So this is that was 3. I haven't done 4 yet, have I? Sorry. So let's look at exam 4. Oh, this was 4. I did do 4. Did I do both of them?
Can I have my exam, please?
Not now. Come and see me at 2 o'clock. Did I do both? Did I do?
You did 2 questions. 4th paper.
I did both 3 and 4.
4th paper, you did 2 questions.
I skipped some questions. And 4? 4. Oh, I got more to go, is what you're telling me. Yeah. Okay. Yeah. I'm getting confused. Okay. Describe what happens when the last statement below is executed. This guy. So the literal string is promoted to the type of the maps key, which is a standard string. Since that's since it has a suitable promotion constructor. If it didn't have a suitable promotion constructor, it would fail to compile. Key is used in a hash function to find a specific bucket, linked list of key value pairs with roots stored in the address computed by the hash function. If the key zong exists in the unordered map bucket, then its value is overwritten with a value 23. If the key does not exist in the unordered map, then we create a new pair and insert it into the map. These two things that were the primary score carriers. Okay, I wanted you to say everything, and you didn't get a 1.0 unless you said everything. But the first 0.95 are carried in these two statements. And I have a demo. So let's. So there's a demo in MT4Q3. So let's look at MT4Q3. So here's MT4Q3. Set this as startup. So. Oh, this is just this is just a display function. You can ignore all this. You want to look at it, but it's just setting up a display function. But so here I have a demo map with Pei, Amber Car, and Zhang. Zhang? How do you pronounce it? Zhang?
Yeah.
Zhang.
Yeah, that's where.
Zhang. Okay. So you're all, some of you are represented in these examples. I try to, okay. So, and if we run it, I'm just showing you, here's a class unordered map. Now I've added this, so this didn't exist before. Now I've added it. Now I changed it, and so here, same number of elements, but now the values changed. So this just demonstrates that exactly what I said is true. Okay. That's what I like to do in these examples, convince you that. Write all the code for a node class that holds a variable of unspecified type and can link to other child nodes. Instances of this class can be used by a graph class to represent its vertices. And I got lots of code all over the map on this one. But basically, here's pseudocode. Node T is a container class that holds T, a value of type T, and a standard vector of shared pointers and nodes, and that's it. That's the whole thing. Now, I added marking and unmarking, but that wasn't needed for the answer. Okay. It's useful for the graph walk. I had it in the graph walk, but it's useful for the graph walk, but I wasn't expecting it in the answer. If you provided it, great. I changed my syntax a little bit from the GraphWalk demo I handed out. In the GraphWalk demo, I had declared shared pointer as to be a shared pointer of node of n. And I changed that to n so that we could see here clearly that the shared pointer is in fact pointing to a node. It's a little more verbose. I'm typing a few more characters, but I think it's better because it's really clear exactly what it's doing. That's always a good thing. Even if it takes you a couple more characters, it's a good thing. By the way, you can see me right after class. You can see me right at the end of this. As soon as we're done talking, I'll give you your example. Okay. So now, this class assumes that V is copy constructible and copy assignable because I didn't provide copy constructors and assignment operators. And your answer really wasn't totally complete unless you said that. If you didn't provide them, why didn't you provide them? So I know that vector is copy assignable, copy constructible, and I know that string is copy assignable and copy constructible, and I know bool is copy assignable, copy constructible. The only question is my V value, and I'm assuming that it is. So I should say in my prologue to the class assumes that V works only if V is copy assignable and constructible. And it's not dangerous because this will fail to compile if it isn't. Okay. A statement that does an assignment will fail to compile if it isn't. But most of the cases you would use, it is. So I think that the use of standard shared pointer is essential in this class. Essential. Not using it as an error. If you use standard pointers, you can get it to work, but then a client has to ask, should I delete this pointer or not? No way to know. I mean, one part of the code may have constructed those nodes, and some other part of the code is using that graph or something. And the question is, should I delete those nodes? I'm done. Should I delete those nodes? I don't know. Were they created on the stack? If I do, I'll throw exceptions. I'll throw debug assertions is what I'll throw, not exceptions. Okay. Standard shared pointer takes care of all those problems. All those problems go away because I know that if I use standard shared pointer, what it points to is created on the heap. End of story. And also, it's reference counted. So if I delete it or let it go out of scope, no problem, because if somebody else is still using it, their pointer will be in scope, and the reference count won't be 0, so the object will live. So I think using standard shared pointer here is an essential part of a correct answer. Describe how you would safely share a string between two C++11 threads where either of the threads may read or modify the string. And, so either, so I declare a static mutex, and I have to pass the shared string by standard reference, otherwise it's not sharing it. So, there are quite a few answers that either the string wasn't shared or the mutex wasn't shared or neither of them wasn't shared. So, because they were, if you don't understand that the string will pass its arguments by value, it isn't going to work. You need to use standard reference. Draw a package diagram for your design of the repository. So here's, my package diagram of the repository. And, it may be, I didn't insist you had all these parts. You could have gotten a grade of 1.0 if you didn't include the client. I think that you probably want a storage manager, because I don't think I think check-in should be worried about versioning and authorization, checking against ownership policies, and not have to worry about how the repository intends to store stuff. So, that's the way I broke it out that way. But what I was mainly looking for was, A, that you knew how to draw a package diagram. Probably 1/4 of you put class symbols, class relationship symbols on the packages. That's absolutely wrong. Okay. So the only thing on a package diagram are the package symbols and dependency arrows. That's all that's ever on a package diagram. And I've grouped the several packages in NoSQL-DB just to keep this from getting too complicated. So one good reason for using a storage manager is that now I've isolated the NoSQL-DB. I can isolate this just to the storage manager if I want. Depends on the design details here of check-in, check-out. You might decide, gee, I really want to let these guys, I don't want them to have to go through the storage manager to get the information they need, but But my mental model is, from a functioning point of view, that the storage manager is responsible for both the metadata and where things go. Again, as I haven't implemented this myself, and so when I implement it, I might change my mind about the decision. I might say, gee, this is getting a whole lot more complicated than it needs to be because I didn't give it access to this guy. But at least that's a really good starting point. When will a standards conforming C++ compiler invoke a move operation on an instance of a class that provides that operation? The instance is passed by value from a temporary or assigned from a temporary. That's it, baby. Also, if my user declares standard move, then that's convincing the compiler that even though you don't think it should be moved, I want you to move it. I'm promising never to touch that source object again. There's also a standard forward that I haven't talked about yet, didn't expect in your answer. We'll talk about that when we talk about template metaprogramming. So here's some obvious cases. This is a temporary. There is no sum. This S1 plus S2 doesn't have a name. Temporary. Anything without a name is a temporary. So I am assigning this temporary to S, so absolutely we'll use a move. Here I'm internally generating whatever that type V is in this function, and so that's a temporary in this function, so I'm going to use it. And here I have a name. This is a L value, any named thing, left-hand side L value. But because I called move, the compiler will. It's my risk, okay. I assume the risk. I'm promising never to touch V2 again. Or to reestablish its value, its valid data. Okay. That was the exam. I won't say piece of cake. You wouldn't believe me if I said that. Okay. Bear in mind, I have elaborated these answers for you as an instructional tool. Had I been sitting in one of these seats taking the exam with you, my answers wouldn't be that long. It wouldn't be time for me to make them that long. Okay. I hope that they would be as correct as all of these. Okay. But so don't be discouraged if you say, "Gee, my answers weren't that elaborate," because understand that I'm doing this as an instructional tool. By the way, if you are unhappy with your midterm grade, some of you should be. I'm going to have a normal help session at 9 o'clock in this room on Friday, but I'm going to have another session at 2 o'clock that I call the Phoenix session for aimed at those people who are dissatisfied with their grades. So what can I do from here to maximize what I get out of this course? We want to address that. I'm going to tell you right now what I'm going to tell you then. And that is that the best thing you could do would be to go over all 4 exams until you know absolutely everything about every answer to every question. There's no you understand every single answer in all its detail to every question on all 4 midterms. And by the way, it's a great way to prepare for an interview, for a job. You know, if you want a job that has you writing C++ code, great way to prepare for interviewing for those jobs. It really is. The span of this exam, you can't do this without understanding most of the language and how it's used. You understand the design, and you understand the language that implements your design. So. Okay, there is a midterm makeup. So the first thing you're asked, there's 2 parts. The first part is for you to do a critical analysis of your errors on the midterm. That does not mean shovel my answers back to me. I know my answers. I don't want to see them again. I want to be convinced that you understand what was wrong with your answer. You're welcome to refer to my answers to help you figure out what was wrong, but what you say here describes what you did wrong and what you should do to fix it. You don't need to shovel back all kinds of code that I've written for that. You don't need to do that. So, but you need to do a credible job of all 7 questions, every single one. You know, if you got a 0.98 on one, you know, your answer is I got a 0.98, and I'll smile and we'll go on. Okay. But other than that, I want to see a good critical analysis. Not just one sentence, one sentence, one sentence, one sentence, one sentence. That'll get you about a 70. Not everybody who does a midterm makeup gets an 85. Some get lower than their midterm score. Now, I make a contract with you, you will get the higher of the 2. I won't reduce your midterm score if you get a lower grade on your midterm makeup. So it's always to your advantage to do it. Now you say, but I got an 84.7, should I do a midterm makeup? And I would say, yeah, but only after the semester is over and you've taken care of all your exams and your other courses, you know, you've gotten everything, you know, and over the summer, go back over it, and, you know, because it'll be time well spent. Then there's some questions. These are very midtermy-like questions. Implement a thread-safe vector that provides the same functionality as a standard vector, but supports safe read and write access by multiple concurrent threads. Yeah, that's, you know, so. You know, not every one of these is a new question. Some of them, a few of them came from earlier midterm makeups. I have not published answers to any of the questions. There's 10 questions here. I haven't published the answers to any of those 10 questions, but you know, a few of them you'll find floating around. You know, your seniors. You know, but don't do that. You know, do it yourself. You got 2 choices. I could do the same kind of thing that got me into trouble in the first place. I didn't pay attention, I leaned too heavily on other people. Or you could say, I'm really unhappy with what I did, I'm going to fix that, I'm going to pay attention, I'm going to work hard, I'm going to do it myself. Right? Okay, so is there anything left to talk about? I think that's it. So the midterm makeup is due on May 8th. So for most of you, I hope that'll let you get your exams out of the way and still have time enough to come back and do this. I won't accept them after May 8th because I have to turn in my grades. By the way, projects 1, 2, and 3, the late fees were 1 point a day, but for project 4, the late fee is 5 points a day because I have a very short amount of time to get my grades in. So I need a forcing function. That's my hammer. Okay. So call me Thor. 5 points a day. Okay. So, now you probably wouldn't call me Thor, but I'm too old and scrawny for that. That's the model. Okay, any questions before we break? For any of you who are here that didn't get your midterms back, you can come up, queue up here, pull out your student IDs, and I will give you your midterms. Okay, key. Okay. Thank you. Lynn, you want? Lynn? Oh, okay. Yeah, that is a you. Kind of looks like a. Yeah. If you want your exam, come and get it. Let me see your student ID. Oh, Swamp Mill. Yep. I know your face, I know the name, but are you here?
Do you have your midterm 1 or 2 here? Do you have midterm 1 or 2 here?
I do. I have midterm.
Yeah, I am midterm 1.
Oh, okay.
Yeah, thank you.
Yep.
好了更好，好不了跟我一起走。
Yeah.
哦，对，如果是给其他人，也没不好。I'm gonna get your signature.
Yeah, sure.
Oh,
You can do it.
Okay, here.
I have a pen. I guess we'll have to come to my office.
Yeah, that's
oh,
okay.
No, I got a pen right here.
Let's go to your office.
Yeah.
I'm not sure what to write here.
Obviously.
In this independent study course, what course number?
So you are, so this should be
670?
670.
Just right here, the number. Yeah. Yeah, okay.
And
Yeah, if
this is
if it is
experience credit.
Oh, thank you. Yeah. As I remember that your example is 670, but I am not that sure.
Yeah, I'm pretty sure too.
Okay. Yeah. And what's the class number? Because
That's for the registrar, signed by the registrar.
okay. Yeah. Yeah, I will sign it later.
No, you sign it now.
Oh, okay, yeah.
I don't sign anything that isn't fully filled in.
Yeah, it is.
Thank you.
So others.
Yeah, so, I don't think that gets filled out to the department chair. I think if you just take it to Cynthia, she'll get whatever.
That's enough to get to the
Yeah,
things.
I think you can take that to
Okay,
Cynthia.
yeah, and here is the.
I don't need to do anything with that.
Oh yeah, I think so. Yeah.
This is
that's
the only
great.
one I signed.
Yeah, that's great. Thank you.
Where is it you're going?
Synopsis.
Synopsis.
Yeah.
Fantastic.
Yeah.
Yeah.
And
yeah.
Ishan also there.
Yeah.
You remember him?
Yeah.
Yeah.
Yeah, good.
I think I am
Di ba talaga tulog
be
siya?
working with him in the same team.
Good.
Yeah.
Good. Yeah, I'm glad that worked out for you.
That's really important, I think.
Yeah.
Maybe if I furthermore get a full-time job later, I may also want to be on your website.
Yeah, absolutely. So all you gotta do is send me a little short bio and a picture.
Yeah,
and I'll
of course.
put you up.
Yeah.
Yep.
Yeah. Thank you.
Great.
Yeah. Bye bye.
See ya.
मज्जा.
एक मिनिट पेपरवर लिहून दे सगळ्या इन्स्ट्रक्शन
अरे
एकसाथ
तू मला नको ओरडतो.
लिहून दे एक मिनिट हा ओरड नाही मी बोलत आहे पेपर घे त्याच्यावर प्रिंट कर
बोलते.
हा स्क्रिप्ट मला पटत नाही हा. असा स्क्रिप्ट
42
बोलायचं
झालेत.
नाही. ते गांडी जावली ती शिफ्ट
तुझी शिफ्ट आहे. 42 झालेत. चला लवकर पळ.
परत तेच
चल बाय.
See, your spring break wasn't long enough. Still tired. That's the paradox. The more you get, lazier you get. Or more relaxed, not lazier. Lazier is not politically correct. I'm sorry. Is it because of the slow pace? I've been told. Oh, this page. I am actually doing my I want to. I have spoken to him about this. A PhD thesis. It ticks me off. That are related to the home. Oh, yeah, exactly. Yeah, it's frustrating. My yes, you probably have gone over this in the past. Or have I? Higher level of before it is. Originally, I am from um, southeast, southeast, near Greece.